engineer's reflection on the evolution of technology. And the other thing around your previous thing, I want to start this off by telling a story. And this is 1978, and I was attending a conference in San Francisco at the St. Francis Hotel on digital display technology. And one of the mornings of the conference, my partner, Roland, who was a 60-year-old German-born trained PhD physicist, and I decided to go have breakfast at this little cafeteria diner next to the hotel, and I love diners and cafeterias, so we headed down there. And after going through the line, we sat down next to this very old-looking gentleman who had a formally dressed and had the badge showing that he was attending the conference. Roland, my partner, was a very friendly, outgoing, talkative person. Talked to him and said, how did you like the conference? And somehow they knew each spoke German, and they talked a little bit in German, but it got back to English because I guess I was there and they were polite. And this old gentleman was a PhD nuclear physicist born in Egypt. And he trained in Vienna for his PhD in the early 30s. And I think at least that's, I'm not 100% sure of the date, but somewhere in that period. And he had the chance to attend some dinner meetings that people like Albert Einstein, Heisenberg, and Planck had, where they discuss their research, which I found extremely mind. That was to make contact with that kind of technology in that period. And in the conversation, he talked about his rules of problem solving that got passed down to him. And so I thought I would pass those rules, which I think are important. You can look at the results of technology, but it really is a process of problem solving. And his rule, let's see if I can, his rule 1 was life seeks simplicity and balance. There is a normal thing that things, when you're in a real tough problem, always go for simplicity, not complexity. Structures only get as complicated as they absolutely have to. Excess complication is extinction when things change. Rule 2 was happiness is assuming piecewise linearity. And that's to say, again, when you're in a complicated problem, break it up into solutions that you know how to solve, and then put the whole thing together. Rule 3 for him was 2 and 2 can equal 5 for large cases of 2 and small cases of 5. You have to recognize that perception is not exact. In fact, that was part of Heisenberg's theorem, if anybody wanted to look at Heisenberg's theorem. And we get our best results for looking at a broad spectrum of data from many perspectives. And then this is rule 4. It's the most difficult to understand, but states that maximums always occur at the intersection of the boundaries of its limits.
I'm going to say that again.
Maximums always occur at the intersection of the boundaries of its limits. You know, and that there's a whole field of mathematics that talks about linear equations and stuff and boundary thing. And this is something that I've been really working on. It kind of goes to the thing that physical structures get their form from their limits. You change the limits and the form changes. I like the idea of, in research for black holes, the matter goes into the black hole and reverts, at least according to the theory, to pure energy and doesn't have the structure you think in normal Newtonian or relative theory of things. But then when it escapes, it re-establishes its structure and rules. And so they got theories that, oh, on the boundaries of black holes, the rules rely. But in my opinion, and according to this, the rules are because of the limits of the structures of our universe. So, and anyways, I could talk hours on that subject. So those were the ones that Muhammad, the Egyptian physicist, talked to us about. Over the years, 65 years of my professional career, I've developed two more, which I use. One is that I always look to nature and the human body for how they solve the problems that I'm interested in. Nature and human life forms have had billions of years to solve billions of problems and come up with pretty good answers. So I always start there. Then the last one is a little leery because it contains the word shit in it. And I don't want to be offensive to anybody, but I get a kick out of all of our grandkids, or our grandkids in the age of kind of 6 to 8 love to talk about poop and pee and stuff like that. But so I'm going to just do it, and I hope you're not offended. The rule is when you're drowning in a tub of shit, the only thing that is important is which way is up. The thing here, it's a metaphor for first recognizing that you're in this tub of shit, and that it is shit, not champagne, and that you want to get out. Then the next thing is what to do about it. So there is, again, you could spend hours of discussion on the meaning of that topic. The closing point to this story is that I had the gift of living in one of the most exciting times in human technical history, 1942 to 2022. And it was great adventure and meaningful work. Not all good, just a lot of change. Today, we face a different set of problems. And again, problems determine structure. Because of limited resources and global warming, there is a time limit on our solutions. We need to be well on our way to balance by 2050, with the next 15 years being the most critical. My message to everyone is you must get involved some way. Start out by understanding the problem, and then let the rules and technology find the way. I talked yesterday with Jim about a time capsule project for the whole fellowship, especially the young. where we bury a time capsule box to be opened up in 2037. This would be a way to put into words, pictures, and videos what we want for the future. The first step to a solution is knowing what we want. Yeah.